Good morning, everyone. Today is Friday, April 3rd. Let's go ahead and dive in. Today is the day where you guys are going to just play a game to help you to remember or to practice, I guess, how to balance equations. And so our folder today for standards, it's just the same as yesterday. And that is SC752B, to develop and use a model to describe how the total number of atoms does not change in a chemical reaction and thus mass is conserved. Remember, we're looking at conservation of mass, the law of conservation of mass. And so we're trying to make sure that you guys understand that whenever we have a chemical reaction, the same number of atoms have to be on the reactant side and on the product side. So we're going to continue. This is like part 2 of what we started yesterday. All right, let's go ahead and jump in. Before we begin, I've got a lot of stuff in my folder today. So I'm just going to show you really quickly. I'm not going to go into everything, but just kind of show you what everything is, because some of you will need it and some of you won't need all of this stuff. So first things first, you guys found my video for Friday, April 3rd. That's right there. There's the link. We're going to go to that in a second. Yesterday in Thursday's video, I mentioned that I was going to put a folder on the front page of our science classroom homepage, whatever. And I'm just finding all kinds of really neat things, and I want to put those in this folder so that if you guys ever get bored or you don't have anything to do, these are science things that I'm finding that don't really have anything to do with what we're working on right now, but they're really cool and I'd like to share them with you. So there's a video there that kind of explains where that is, what I'm doing, and then yeah, I'll just let you watch that. I'm not going to explain any more about that. And then the last thing is, today I wanted to give you some extra help. So one of the most challenging things that I'm coming up with, or that I'm finding about e-learning, is it's really hard for me to look at you guys and ask you, do you understand everything okay? And some of you are emailing me saying, I don't understand the model experiment. I've looked at some of your model experiment, or not the experiment, the model explanations for lead and fertilizer, and they're just not quite where they need to be proficient. And so it's hard because I can't just work with you one-on-one. I can't just draw you a picture on the board or have like a conversation back and forth. So I'm doing the next best thing. I went ahead and I made 2 videos, and I've got the links to those videos in this folder. So if you have any questions about how to complete that model homework assignment so that it's proficient and you can get the credit for it, then watch the video in there. And you will be receiving an email if you need to watch that video, okay? The second video that's inside there is, I took some time to explain chemical equations and balancing chemical equations just a little bit more in depth. So if you're at a place where you're like, I totally get this, I know what I'm doing, cool, just move on with today's lesson. Watch the video first, obviously you're doing that, and then move on and play the game. If you need to go back and do a little bit of review, then that's where you're going to find those videos. Okay, let me know as always if you have any questions. All right, so you're going to get to the video, you're going to get to a place where I want you to click on this balancing chemical equations link. And this is going to take you back to that website where we were at yesterday. And I was using this to explain to you how to balance equations. And so when you get to that link, go ahead and just push the play button here. And I'm going to show you where I was. And so if you need a little bit more practice, then go in here to introductions. And in the introductions, don't forget, you're going to hit your balancing tool. And always start with 1 molecule of each on the product side and on the reactant side, so that you can now start to figure out what you need to change, how many of each that you need to work with. This is where we made ammonia. Right here is where we separated the water. And then right here is where we combust methane. So if you need more practice, go through and practice, okay? All right, if you are good and you're ready to go, then come down here where it says game. You're gonna click on game. The games are designed to have, they've got 3 different levels, and they get a little bit more challenging as you move up the levels, okay? You get points based on whether you were able to balance it right away at the beginning, or if you needed to have a couple tries before you balanced. So let's go into level 1, and I'll just show you the first one. So this is taking a look at these chemical equations, and remember, we're going to go ahead and just add 1 to each one, okay? It looks like this is different than the one that I did practicing myself, so that's good. That means it kind of rotates, and so you don't get the same ones over and over again. That's good. So you could go through theoretically and play this game multiple times and get to practice multiple. It's not like you're just going to memorize the numbers and then move on. You really have to work to perfect this. So that's great. All right. So you'll notice here that I don't have those scales, so that I can't tell just visually where I'm not balanced. So you're really going to have to take a look at the models. So it looks like I've got 2 big molecules, and they're kind of gray, and 2 small molecules that are white. And just because I know, you can also look right here, the hydrogens are the small ones, and the gray ones are the carbon molecules. So in one molecule of C2H2, I have 2 molecules of carbon and 2 molecules of hydrogen, plus a hydrogen molecule that has 2 molecules. Remember, hydrogen does not exist in nature by itself. It always is going to have 2 hydrogen atoms in that molecule of hydrogen, or H2. So that means I've got a total of 4 hydrogens and 2 carbons over here. So then I'm going to come over here and go, okay, now I've got 2 carbons and 6 hydrogen over here. So what do I need to do to change this? Well, I'm going to get it wrong on purpose just so that I can show you what it looks like. Okay, I'm going to say I need, I'll make sure I get it wrong. Nope. I'm going to make sure I get it wrong. I think I need another molecule of that to balance. So you're going to make your choice and then check. Didn't get it right, so that means I need to try again. So I'm going to show why. I'm confused. I don't know why I got this wrong. So I can show why, and there's where my balance visual comes in. So I can see that I've got 2 carbons in my reactants, and I've got 4 carbons in my product, and then 4 hydrogen and 12 carbons over here, or hydrogens over here. So I need to try this again. So go ahead and hit try again, and I'm going to bring that back down, and let's try this. So to me, it looks like I've got 2 carbons over here. Do I have 2 carbons over here? I do. And now I've got 1, 2, 3, 4, 5, 6 hydrogen. Do I have 6 hydrogen over here? I do. So let's check it. Good job, we did it. So then we move on. Notice that my score here is a 1. If I would have gotten that right on the first try, I would have gotten 2 points. So you're just going to work your way through, keep challenging yourself, and keep practicing. I know this is kind of a difficult topic, kind of hard to understand and wrap your brain around. But if you do this kinesthetic activity, I think it's really going to help you guys understand the idea. We need to have the same number of atoms on each one. Okay? Let me know if you guys have any questions. That's your homework. You're just going to play the game today, okay? I will talk to you later. Bye.